Anton Kreuzkamp and Thomas McGuire, who will talk you about QML Web, running Qt applications on the web. Please give a hand. Okay.
Thank you. Thank you. So, good morning and welcome to our presentation about QML Web. My name is Anton Kreuzkamp. I'm working in the KDE community for 3.5 years now, and I just finished secondary school this year. So actually, this is my first presentation I'm doing outside school at all. So I must say I'm quite happy to see that some of you are not completely awake yet. So yes, Thomas, do you want to present yourself?
Thank you. I'm not quite awake yet either. My name is Thomas McGuire. I'm a software engineer at KDAP. And at KDAP we do consulting around Qt, and as such my day job is doing Qt and C++ almost exclusively. On the other hand, my HTML knowledge is not quite big. I know like 5 HTML tags. In HTML5 they deprecated 3 of them, so my HTML knowledge is really not up to date. So why I am in a presentation called QML Web, which is obviously about web technologies. I have a keen interest in the QML engine in Qt, so I wanted to know how it works. I examined that, I blogged about it, and last Dev Days I had a talk about that. So I know how the QML engine works internally, because that's an interest of mine. And at the last Academy conference, that's the KDE conference in Bilbao, Anton approached me and asked me lots of questions about the QML engine, which some of them I could even answer. So this is why I'm here. We'll be talking about QML engines, and my only part is talking about how the Qt QML engine works, and Anton will do the rest since he's the HTML expert, which I have no idea about.
So, yes. You know QML, I guess. It's that nice, pretty language to write your complex but still fancy Qt application you are with. And the web, well, it's obvious. But what happens if you put QML and web together? Will it be a new QML module to implement a web server in QML? As the title already says, no. It's not about bringing the web to QML, but about bringing QML to the web. It's all about the question, what if we could use QML to write web applications? And that is what I want to talk about today. Why at all use QML for web applications? We have HTML, we have CSS and JavaScript. It can do everything we need. Why would we need a fourth language? The next step is, what at all is that QML Web this talk is all about? Then how does it work? How do we teach the web browser property bindings and anchor layouting? In this chapter, we will not only talk about how QML Web works, but also about how the Qt engine, the QML engine of Qt works. So that's where Thomas will talk, and we will then compare it to how QML Web works. After that much theory, you will not only ask, how does QML Web work, but also, does it work at all? How well does it work? And finally, I want to talk a bit about the history of the project. How did it all begin, and how would I like it to continue? So let's begin with the motivation. Why use QML on the web? In this example, it's about layouting. We have an image of the Qt logo, and we want it to be centered inside its parent, inside the circle. So in QML, we have an image, set the source, and say anchors center in parent. It's one line. In HTML, it's one line. Oh, no, it isn't. So in HTML, we need to separate between horizontal centering and vertical centering. Horizontal centering is doable in one line. We have to tell the parent to center its children. The vertical centering, well, it actually isn't supported at all. vertical centering in HTML is only supported inside tables. So what we have to do is to create a table with only one cell, and then we can say center your children. So we have to do all this stuff to center the element inside its parent. In QML, it's only one line. So the next thing, as this one was actually about QtQuick, not QML itself. So let's compare QML with HTML or JavaScript. This example is about what happens if we want to change a property of an element. In this example, we want to change the width of that rectangle to 100. In QML, we write one line with rectangle.width is 100. So we access the element using its ID and then set width. In HTML or JavaScript, we need to fetch the element by its ID, and then using style.width, we can set the property, the CSS property, to 100 pixels using a string. So what happens if we want to increment that? In QML, it's one character more. We need a plus between the equals. In HTML, we first have to extract the value from the CSS string by cutting away the pixels, cast that to a number, then increment, and then write it back to CSS.
Yeah, and by the way, this is still how HTML applications work today. So this is what I've seen in real-life code, even in 2013. This is how HTML apps are written. You basically have a document object tree model, and you modify it with JavaScript even today. So an HTML app is basically a collection of div tags, which are manipulated using JavaScript. And you can already see that that's not quite, it wasn't quite invented to write apps because, well, it's called document object model, right? Not app object model. HTML was clearly written for document and not for apps, and I think this code snippet here really shows that. And QML was invented with apps in mind, and you can clearly see that's much easier.
Of course, JavaScript libraries like jQuery can make this one a lot easier. But there is one thing I want to show you that no JavaScript library can make really better. We need this. Oh, sorry, I forgot one example. It is about property bindings at first. In this example, we have a simple indicator that is supposed to show us if the US government shutdown is still active. So we have an object government, and it has a property is down. And this rectangle should change its color depending on whether the shutdown is active or not. So we set color to a JavaScript expression government is down, and if it is, be red, if not, be green. If we want to do that using JavaScript, we can't do that actually. So we need something quite complex. We can do that property government is down using object create property. With this method, you can create a property and set transparent getters and setters, like you can do with QProperty and Qt. So we set a getter function that is returning is down, and a setter function that will not only set the new value, but also call a callback. So we can do a callback to this function change and then reset the color of the rectangle. Also, this is something, for example, AngularJS does that and enables something like property bindings. But now let's come to the example no JavaScript library can actually fix. In this example, we want to create a list in real HTML5 applications, we need to create content dynamically. We do that using HTML. So here we need some HTML. I wanted to say we do that using JavaScript to dynamically create the content. So we need some HTML, some CSS, and some JavaScript to get a clean separation between UI, style, and our business logic. On the other side, in QML, everything is cluttered in one file. So we have a neat separation versus utterly cluttered. Let's have a deeper look. And what does the UI part, the HTML, tell us? It tells us we have a container. Well, what does the CSS part tell us? It tells us we have some element class item, which has the width 200 pixels, the height 50 pixels, and its content is centered. That tells us a bit more, but we still have no clue what is the meaning of this item. So let's look at the last part, the JavaScript. Here is where we find the rest. This for loop creates the UI. So actually we have our UI in the business logic. And we have that in with each JavaScript library that makes this way easier, but we still have the UI in the business logic. So actually this is the content in a real JavaScript application. This would be done using JavaScript dynamically created. But this tells us please create a list. Each element should be a div of the class item, that's the meaning. It should have a background color coming from the model and a text coming from the model. And exactly that is what we're doing in QML in a declarative manner. Here we have our content that would be dynamically created, but we say we want a column with dynamic created content feeded by my model, and each element should be a rectangle 200 to 50 pixels. The color should be the background color from the model. Inside we want a center text with the name from the model. So the conclusion is, here we don't have any business logic. We only have UI. In HTML, we need JavaScript to create the UI. In QML, we only have the UI. So if QML is so much better for web applications or for applications at all, why are we still stuck with HTML? That is the question Toni Nykänen, Pietu Pojalainen, and Larry Pime and myself wondered, and the result is QML Web. QML Web is a BSD licensed open source JavaScript library that you include inside an empty web page. And QML Web will fetch QML code from the server, parse it, interpret it, and render the website out of it. So, of course, as we are in a poor JavaScript environment, we cannot simply use the QML engine that Qt provides. So what we're actually doing is to implement a completely new QML engine just written in JavaScript. That sounds pretty unfeasible, doesn't it? But the web browser gives us almost everything we need. We don't need to implement a new JavaScript engine that is already in the web browser. And we don't need to care about rendering. The web browser does that for us. So everything we need to do is to parse the QML code, translate it to what the web browser understands, and to create an object structure that makes the JavaScript that is included inside the QML code valid. So now it maybe sounds a bit more feasible, doesn't it?
But even still, even though the web browser does a lot of work for you, I still find it very impressive that you and two other guys basically re-implemented the QML engine in JavaScript. I had a look at the QML engine in Qt. I don't know how many people worked on that, but certainly a lot, because it's a really big, complex beast with binding code, with a virtual machine interpreter, a bytecode interpreter, with a JavaScript library interface, with meta object systems. So it's really a really big, complex piece of code, and 3 people re-implement that with JavaScript. That's quite impressive.
Thank you. So, how does it work? When in this chapter now, we will, for each of the sub-chapters, we will first Thomas will tell you how things work in the Qt QML engine, and then I will show how it works in QmlWeb. So,
yeah, that's right. So Anton here is the blue color, I'm the green color, and you guys are all familiar with Qt. That's why we'll talk about the Qt implementation first. So just to recap how that works, then we'll draw a parallel, and Anton will tell you if it's the same in JavaScript QML or it's a different implementation, and what the difference is.
yes.
Okay, let's start with actually loading a QML file. Who is responsible for loading a QML file? So you have a QML file, and who loads that QML file? In Qt, it's quite easy. You have C++ code here. Somewhere, probably in your main function, you have a QtQuick view that you instantiate, and you pass your main QML file to that QtQuick view. So here, and the QtQuick view probably will pass it on to the QML engine underlying. So it's always C++ code that in the end loads the QML file. And that C++ code is either in your custom C++ application, or if you have a pure QML application, it's a QML scene or QML viewer. So it's done by C++, but QML Web doesn't have C++, so who loads that in QML Web?
Yes. So in QML Web, it isn't done magically also. So we still need some HTML. We need a pure HTML file, and we need to include QML Web from this file, and we need one piece of JavaScript to instantiate the QML engine and to say it load main QML. It's actually the same like in C++. Then QML Web will do a XML HTTP request to the server to get the QML file, will get the QML file from the server, will then do its work, parse, interpret, and then it will tell the web browser, create a div with that size, and it should be there and stuff, and so it then tells the web browser what to actually display. So the next question, how does this do that? So to parse and create, to know what it should display. So let's start with Qt.
So in Qt, it's handled all done internally by the QML engine. The QML engine loads a file, then it throws a parser at the file. And the parser does what all the parsers do. It creates an abstract syntax tree. So it has a tree of the elements in the QML file. QML engine will look at that tree, will see, okay, there's a rectangle element and there's a text element in there, and it will create the corresponding C++ item instances there. And that works because each QtQuick item is derived from a base class. You like the transitions, right? Yeah. See? Amazing, isn't it? So in Qt, there's a base class QtQuick item. Each class derives from that. It's a standard C++ class, so all QtQuick items are basically C++ classes, and they are registered with the meta object system in Qt. So here we tell the Qt meta object system about our class. With the Q_property macro, we tell the Qt meta object system about our properties, and that is how the QML engine knows from the AST what classes it has to create and what properties it has to set, which we'll see on the next slide. Press once again.
Yes.
Okay. So on the left-hand side, you'll see an AST. That's the abstract syntax tree. I assume actually that the abstract syntax tree will quite look the same in QML Web, which we'll talk about later. And in the abstract syntax tree, the QML engine knows, okay, there's a rectangle here. What it simply does when it sees a rectangle node, it will create the corresponding C++ class instance. Same when it sees a property binding or property assignment, which is a UI script binding AST element, it will call the property setter, which it knows from the meta object system. But this is actually a lie. It's not actually working like that. Since QtQuick items come from the plugin system, we can't mention the name because there's no header known to the QML engine. QtQuick items are a totally separate library. They come from a plugin. So we actually use the meta object system indirectly instead of calling things directly, since we don't know how to do this. So to sum up, the QML engine in Qt examines the abstract syntax tree after parsing the file, and then it instantiates the stuff, C++ item instances, because it knows from the meta object system which name corresponds to which C++ class.
Yes, in QmlWeb it's almost the same, but of course in JavaScript we don't have classes at all. We only have constructor functions. So what we do, each property type, each element type, sorry, is a JavaScript function, like QML rectangle, that comes from QML item, and we have one function, create simple property, and that will create a getter function, a setter function, and create the property using that function you already saw in the last example to create a property from a getter and a setter function. Then we need something to actually translate, that's everything, and we need to set the default value. And then this function is pushed inside an array that knows the name and the function. I see just here there's the name missing actually. So here is the name, rectangle, and then QML rectangle.
By the way, JavaScript doesn't have signals and slots out of the box. And what the JavaScript library in QML Web does to emulate that is it uses callback functions in a connect statement.
Yes. And then this is similar to this C++ code. Element, an object is created using this line of code and passing the meta, which is the parsed code, and then the color blue is passed to the property simply using that syntax. So the next question is, how does bindings work? Here we had a simple assignment, and we just needed to set the property to red or blue. I think it was blue. In QML we have these property bindings I just showed you. So how can we create these?
Okay, in the Qt engine, in the Qt QML engine, it's actually quite easy. So we have our property binding here. We set the the color property, depending on other property. And what the QML engine does, it actually needs to link it. So each binding here is a JavaScript expression. So in C++ we can't evaluate JavaScript natively. So what we do is we link against a JavaScript library. Right now in Qt 5.1 that is the V8 engine. And in Qt 5.2, Lars Knoll wrote its own JavaScript engine for it. And what we do is we pass that JavaScript string, that string here we simply pass to the JavaScript engine and let the JavaScript engine evaluate that. So we'll ask the JavaScript engine for the result of that expression. Then we simply pass on the result to the property setter and set that result to the property. But if you have a property like lost and an object like game, it's all objects coming from C++. How does the may I have that puppet?
Yes, you may.
How does the JavaScript engine know about our C++ objects like game and lost? Well, it doesn't know about them. What happens is that the JavaScript engine will start evaluating the expression. It will know, wait a second, I don't know what this game ID here is. And it will go and ask the QML engine, I don't know what that is, please tell me about it. QML engine goes, okay, the game, it's an object, here's the pointer address. Then the JavaScript engine continues the property evaluation. It will see the lost property here. It has no idea what that is. Again, it will ask the QML engine for it. Then the QML engine will see, oh wait, someone is accessing the lost property. I'll make a note here. In my list of captured properties, I'll make a note that someone tried to access that property. And then it will tell the JavaScript engine what the value of that property is, which is false. JavaScript engine will return the result, which is, if lost is false, will be green. So the result will be green, and that will be set. The QML engine will get that result and set it to the property. And now happens the magic of bindings. The QML engine takes the list of captured properties here and connects to the changed signal of all these properties. So it connects to the changed signal, to the lost changed signal of the game object, connects to that to an internal slot that will re-evaluate the binding. So what will happen if the lost property changes, the binding will be re-evaluated, and that is how property bindings work. QML engine knows all the properties that were accessed and connects to the changed signals. And imagine it will be quite different actually in the JavaScript QML Web, because first of all, you don't have the separation between JS engine and QML engine. JS is all built in. It is JS in the first place. Maybe, I don't know if Anton will tell me now, if it actually has the concept of captured properties and the signals, the changed and notify signals like here. I don't think in JavaScript properties emit a notify signal when they change, do they?
They do. Oh, actually, of course, in JavaScript, we don't have the separation between the JavaScript engine and the QML engine. We simply create an object structure in JavaScript itself where the JavaScript of the binding is valid. So the JavaScript engine knows game and it knows game.lost. So the rest is actually the same. For each property of the rectangle, for example, we have properties which point to a getter function and a setter function. But we don't only have the getter and the setter, but we only have a function update and the signal changed. So as soon as we set the color, the setter function will be called. And now we still need, the setter function will, of course, now using a simple eval, evaluate the expression of the binding. But still, we somehow need to know that color must be re-evaluated when game.lost changes. So what we do is we have a globally available property variable that is evaluating property. And the setter of color will now set this property to be a pointer to color itself, and now call eval. And that will evaluate the string, and when game.lost is accessed, it will automatically call the getter. And the getter will now look up at evaluating property, what this pointer points to. And it will see, oh, color. So color called myself, so color is dependent on me. So as soon as now we set game.lost, again, the setter function is called. The setter will emit the signal changed, and in the getter function we already connected the changed signal to update, so the update property will be called and the binding will be re-evaluated. So almost the same as in C++ again. The only difference actually is that we don't have this communication between the JavaScript engine and the QML engine.
Well, in some way, you also invoke a JavaScript engine by calling the eval function in JavaScript, right? It's the same as manually invoking JavaScript engine from the QML engine.
Yes, almost. So the last thing is, how does the rendering work? How how does the QML file get actually displayed?
First of all, let me apologize for that slide. I was too lazy and I have a boring list of bullet points, no fancy animations or graphics, sorry. Fun?
Less is more.
Less is more, yeah. So rendering in QtQuick is done by OpenGL, and it's even done multi-threaded. So the QML engine has its own rendering thread where it does the rendering with OpenGL. It uses a scene graph, which actually takes the geometry, does fancy resorting of the geometry to make that as optimal as possible. Cost of that is the code is quite complex. There's a scene graph renderer, there's a scene graph items involved, but it's really, really fast since it's heavily optimized. I have no idea how anchoring works. That's some magic stuff implemented in QtQuick item. And I wonder how that all works in QML Web. I would assume Qt uses OpenGL. QML Web can simply use WebGL, right?
Yes, we could do that, but we would have to do all the same as the QML engine in Qt does. For example, in Qt we have quite huge code just for the text positioning and to do word wrapping of text, for example, which we have to do all manual in OpenGL, and we would have to do the same in WebGL. So what we can do in the web browser, as the web browser supports all that for HTML, we just can translate the QML to what the web browser understands, which is HTML, and the web browser will understand and will be able to render this rectangle out of that code. So what we do when we position, for example, that element, we have the anchor center in parent. We set this. It's actually a binding. We evaluate that and stuff. This signal changed is called. Then we have a function that is connected to that signal, which will update the geometry and will calculate then the absolute position the rectangle needs to have. And it will reset the x property of the element, and that again has a signal assigned to its a slot assigned to its changed signal, which will simply set using JavaScript, using DOM, the style left, the style property left, and set its absolute value using CSS. So it's absolutely positioned at the right position. So that was the theory about how does it work, how can we teach the web browser property bindings, how can we teach the web browser anchor layouting and stuff. The next question is how well does it work? You have seen how it works, but you still don't know, is it actually usable or is it just some nice experiment? So the first demo is what you've already seen. The presentation is completely done in QML using QML Web, and that's the reason why there are all those fancy animations to just show you what is possible. And for the next demo, what about a party of Minesweeper? So this Minesweeper is also done completely in QML, as of course this presentation is running in web browser. Using QML Web, we can simply embed it into our presentation. So this is of course not exactly the same demo we have for Qt 4, where we had Minehunter as a demo for QML, as at least currently no particle system is supported in QML Web. And in Minehunter of Qt, the logic was implemented in C++. Of course, in the web we don't have C++. So here it is done in JavaScript.
So I re-implemented the Qt4 demo in QML Web and pure QML. I had lots of fun with it. It's fun doing a little game. If you want to try it out yourself, there's a URL there. I uploaded that to the KDAP web server, and it was actually quite pleasant to implement. So the core stuff like bindings and so on worked quite well. Well, there was one bug, but Anton quickly fixed that one. What I had some problems with was the QtQuick items itself. So the QtQuick item library, there were stuff missing classes, missing properties, which is expected. It's in the very early stages. But I could work around all the missing bits and kind of had a bit of nostalgia, and it reminded me of the first day of QtQuick. Like, what was it, 3 or 4 years ago? I remember what big mess that was. It was quite similar. But you can see it's already possible to create a complete game with it.
So let's not only show demos, but see what actually is supported and what's not supported yet. What? Wait a minute. So what is supported are all basic element types like item, rectangle, text, and stuff. We have, of course, property bindings. We have signals and slots re-implemented in JavaScript. We have components, so you can use separate files for your QML applications. We have anchor layouting. We have positioners. What we don't have is things like list view and grid view. That is, of course, going to come. We have basic animations like number animations, sequential animations and stuff. We also have behaviors, states and transitions. Well, I think you can read. What we don't have are advanced animations. What is also missing is loader, which is an element type which you can use to lazy load QML files. So you don't have to load everything at once. Currently in QmlWeb you have. Next thing is particle and shadow effects. Using CSS that might seem quite difficult, but actually it's possible. Currently there are the first drafts of support for shadow effects using full CSS for all kinds of web pages. It's currently just supported in Chromium or in WebKit at all. But hopefully it will come in the next years, so we can also support things like shadow effect in QmlWeb.
By the way, while this is still in the early stages and not all UI elements are implemented, it actually supports more than the original QtQuick engine, since it supports buttons, which the QtQuick engine didn't support until this year with QtQuick controls. So it's actually more advanced in one sense.
Yes, of course. As we are in HTML, we are in the position where we can simply use HTML elements like button, like text input, text area, and stuff. So we also have element types to support those. There are quite a few missing still, but it's a work of 5 minutes to implement each of those element types. It's just not done yet. Also, key handling is missing, but as I said, it's work in progress. So the next question is, how well does it work in browsers? You would expect it's a fancy new technology, so maybe in 5 years it is supported by browsers. Let's look. It's actually supported by Chromium 1. Chrome 1. It's not supported by Firefox 1, but with Firefox 2 it works. And only, as always, the Internet Explorer is our problem. So Internet Explorer doesn't support those transparent getters and setters until version 9. And that is something we need completely for QML to be able to support property bindings. And without, it is not working at all. So unfortunately, we need Internet Explorer 9, but today we can, for modern applications, we can almost expect that. So the last question is, how fast is it? We have not made any huge performance tests, but we measured how long it takes to load our Mindhunter example. So with Qt we need 700 20 milliseconds. With QML Web, we need much more. We need over 1 second. It's not very well. It's not very good. But it is in the early stage. I have many ideas how we can improve the performance. And at least it's not so bad that you couldn't use it at all, as Mindhunter is quite complex example already. And it's going to improve. So the last thing is the project history I want to talk a bit about. As I didn't start QML Web, but the development of QML Web already began in the beginning of 2011, when Tony Nikanen first had the idea of using QML for web applications. As he didn't have much much spare time, he motivated his friend Tony. Tony motivated his friend Pietu Pohjalainen to start implementing QML Web. Pietu was searching for a project he could do, so he started to implement QML Web and presented that at his university, where he met Laurie Pyman, who then joined in with the development. In September 2011, Laurie and Pietu hold a presentation at the 30th IEE International Symposium on Web Systems Evolution. It's a conference all about how the web will continue. So at that stage, they already showed a first working draft of QML Web and a first proof of concept. And actually, like it often is with open source project, after the proof of concept, the project didn't really continue and it got stuck. Until last year, I needed to create a web application, and I was looking for a good tool to write web applications. And I had the same question: why can't I simply use QML? And I did some research and found QML Web. So I started to look at it, and it somehow worked, so I started to implement my web application with it. Of course, soon I got the first problems, little problems, I started to fix them, then more huge problems, I started to fix them, and soon I refactored almost the whole library. So now in the beginning of the year, Laurie passed over also the maintainership to me, and in July of this year, QML Web actually became a KDE project. So the goal of this is to get more publicity and hopefully get some more developers, as currently I am the only developer actively working on QML Web.
I contributed, but the only thing I contributed was bug reports, so I wouldn't necessarily call that contributing.
Yes, I had some contributions. I had already also some code contributions, but no huge things yet. So how I would like the project to continue. My plan is that today I find 20 new developers joining in the development of QML Web, implementing features, fixing bugs, and by the end of October we have the first release. So, of course, that won't happen, but I hope at least to find some new developers that help me with developing, and depending on if I find some people who join in, and depending on how much time I have, we will do the first pre-release maybe until December, maybe in a year. But it is going to come. QML Web is not supposed to be just a proof of concept, but QML Web is supposed to be a real web framework. And our goal for the far future is actually not that you can run any QML applications you wrote for the desktop in the web. If that's possible, it's great. But the main goal is to do a web framework that enables you to create a web application that you create for the web and maybe for the web and the desktop with QML. So it's possible that you create one application using QML that you are able to run on the desktop and on the web. But the focus is that it just works, but it is at first that it is possible to write the applications for both. So let's summarize what we learned today. QML seems to be far better for applications than HTML. So we created a new JavaScript library that brings QML to the web. And that library is actually more than just a proof of concept. It's even usable for presentations. So you saw not only, of course, many property bindings, you saw those fancy animations. You saw anchor layouting, positioner, and, for example, for those circles, absolute static layouting. You saw transformations when we rotated, for example, the arrows, which are all the diagrams were also made using QML, by the way, and lots of stuff more. But we still need help, so get in touch with me. You see the mailing list, join us on IRC, fetch the code from Git, or just mail me directly using my email address. So what if we could use QML to write web applications? The answer is we can. Thank you.
Okay, do you have questions?
That's great. So you learned something.
Yeah, I got two questions. One, how big is that library? What size are we talking about?
Currently, it has about 6,000 lines of code, of JavaScript code, without compromise. No,
Compressor.
yeah, compressing. Thank you.
And second, do you support the canvas item?
Not yet, but it would be doable. QtQuick 2 has the canvas element type. In HTML, we only have to create a canvas. It would be work of half an hour, actually.
Okay. Thanks.
I got a question regarding the generated code. If you are working with content management system, you know the situation when unnecessary containers are generated, a div within a div within a div, and you don't really need two of them. So how clean is the generated code, and do you have can you change it somehow when it's
Well,
not
actually, one element in QML is one element in HTML. So it is not completely true. For example, if we create an image, we create a div and an image inside, because in QML you can do, for example, text inside an image. In HTML you can't do that, so we put a div around the image, and if there are children of the image element in QML, we put them in as children of this div where the image is inside. So actually we have, at some points, we have more divs than elements in QML, but most of the time we only have one div per element.
It's not as bad as front page.
Yes, actually.
Thank you.
Thank you. You showed us the way to link the data model in the QML file. Sorry. And I'm wondering how you would proceed to connect the data to some kind of database, something like that.
Currently, it's only doable using JavaScript, but there's one feature we are planning, or I am planning, which is a possibility to connect the QML with a server. So in QtQML you have the C++ code and you have QML code, and those can communicate in an easy way. You can just call a C++ function out of QML and vice versa, and that could be doable in QML Web as well if we see the C++ code at the server. So we can abstract the communication between the server and the client in the same way. It's currently not yet supported, so we need some JavaScript to dynamically create the content. We need some JavaScript to talk to the server, but we are planning to do this, to implement this in a way we can use as we use it in C++ plus QML.
Thank you.
Any other question?
Is it possible to integrate QML Web as part of an existing web page?
Yes, that's actually possible. We only have, when we create in the QML engine, it's possible to pass a DOM element, and that is then going to be the root element of the QML code. So of course, this DOM element is not allowed to have any content, because the content is erased and then the QML code is embedded there. But you don't have to use the body of the element as the root, but you can use any element.
Another question. When I have a C++-based QtQuick application, I can export context properties. Can I export, for example, the navigator object to the QML scene?
Sorry.
In the browser context, right? I have a couple of JavaScript objects, the navigate object, the window object, and so on. Can I export those as context properties of the QML scene?
They are just available. So you can, from your QML code, everywhere where we have JavaScript and a binding and a function, we can just access the window property, because that's the global context we can access everywhere in JavaScript, so we can just access them in the QML as well.
So that would be an easy way to integrate the JavaScript you have on your existing JavaScript page.
But of course we can't use property bindings there, so we don't get notified if it's changed. But it is possible actually to tell the QML engine of a specific property, so then the QML engine will create such a property using getters and setters as well for the property we told the QML engine, and then it's possible to use QML bindings. So we can register any property from JavaScript to the QML engine, and then it's usable inside QML also as property bindings. So as we would do from C++ in C++ and QtQML.
Any other question?
Hi. If you would want to make a more widget-based UI, there are obviously two options: using QtQuick controls, or using bindings to an existing widget library for web, for example Dojo or so. What are your thoughts on that? What would you say is a more interesting option?
Well, what we want to support is we probably won't support Qt components completely, but what I plan to support are all the HTML elements that are available to QML, and of course I'll try to keep the API similar to Qt components. But what I also plan to do is to create a plug-in system, so we can actually create, using JavaScript, a module, a QML module that, for example, exposes all of jQuery UI to QML. So then it would be you would be able to just create, for example, a calendar element from jQuery UI using QML. That is planned to be. It is planned to be that QML Web is possible to be extended in this way.
Any other question? Okay, thanks a lot, Thomas and Anton. And okay, and today's program will continue in 15 minutes.